Here's our topic today. It's called partitions. Partitions. Not math. Not math. Just any day, everyday life. You ever heard of that term? Partition. What are you thinking about? You guys that have heard of it before? Before I show some Google images up here. Partitions. Anywhere? What's up, Jay? Yeah. What do you got?
Like when you're in a car and they have windows.
Yeah. Yeah. You're in one of those fancy rides, right? They got the like a limo or anything that the window goes up and down. That window's called a partition. Yep. It separates the driver from who's ever riding the passengers. Yep. I always think of the library, and maybe because I'm too old for this, but and they still have these at the library. Like you can just sit in a little study. Those are partitions. All right. Think of it like a cubicle at an office. All right. Partitions. That's what it is. Divide something up. So that's what we're going to do today. We're going to that something is a line segment we're going to divide up. All right. So we're going to partition a line segment. So what I need your help doing first is I have line segment up AB. And yesterday we talked specifically about a specific ratio, which was the centroid breaks a median up into a ratio of 2 to 1. Well, can we break line segments up in other ratios? That's what we're going to do today, other than this 2 to 1. So this first one here, line segment AB, I want to see if I can get your help breaking it up into a ratio of 2 to 3. So what I mean by that is 2 congruent segments to the left of a point, 3 congruent segments to the right of a point. So before we do that, can we talk how many equal parts would I need to break this up into if I'm trying to find 2 to the left and 3 to the right? How many equal line segments would I need to break it up into? 2 to the left, 3 to the right. So how many total congruent line segments am I going to have? 2 over here, 3 over here. How many total? 5 congruent segments. So what I need you to do, and don't measure it and divide it. All I want you to do is put points on here. So I have 5 equal line segments up here. All right, 5 equal line segments. And I'm not going to be critical at all. Just give me what you think looks like 5 equal line segments. 1, 2, 3, 4, 5. So I have what looks like 5 equal line segments. Can you draw an arrow to the exact point that breaks it up into 2 to 3? That partitions it into a ratio of 2 to the left, 3 to the right. Where is that point right now? Because right now, take a look. I have I have 1, 2, 3, 4, 5, 6 different points up here. Which one partitions it into 2 to 3? Hopefully we're picking this point right there, 2 to 3. Does everyone see it? 2 to 3. So I'm looking for that point right there. No one's going to ask a question and debate me. Why couldn't it be that one? Right? If I started from B, 2 and 3, right? What's your deal? Okay, let's talk now. I'm going to introduce a new vocabulary term. Directed segments. All right? How do I know I start at A and go to B versus B to A? Directed line segment AB. Anytime I see that term directed segment, that tells me AB, I start at A and go to B. If I wanted to go reverse, ready? I do directed line segment BA instead. And that would be that point right there for 2 to 3. Okay? So watch out for the terms here. Directed tells me I'm going to go right from A to B, or if I wrote it BA, B to A. All right? Will I ever probably switch it on you? No. I probably, even in an honors class, I'll stick with A to B. Okay? So let's get more practice here. One doesn't make us great. So let's break AB up into a ratio of 1 to 3 now. Directed line segment AB 1 to 3. So first thing that you need to do is break it up into how many equal parts? Break it up into 4 equal parts. Yep, so put points on. So AB is broken up into 4 equal parts. and see if you can draw an arrow to the point that would be 1 to 3. Breaks it up into a ratio of 1 to 3. And hopefully we're going to this point here. Okay, 1 to 3. If I said B to A, it would be this point here. All right, but we're going to stick directed segment AB. Good so far. You guys are getting ahead of me now. All right, 2 to 1, 2 to 1. 2 to 1. So how many equal parts? Good talk. 3 equal parts, right? This was our median yesterday. And our centroid? So 2 to 1 would have been that point. Oh, sorry to do this to you. No, I'm not. 3 to 5. How many equal parts now? 8 equal parts, yep. Not that great, but good enough. And this final one, 1 to 1. Just wanted to throw this at you, see who's on top of their game. So how many equal parts? 2, right? Partitioning a line segment in a ratio of 1 to 1 is the same as if I asked for the
Midpoint.
Yeah, there you go, kids. Midpoint. I taught you something this year. Yes, midpoint. Good job. Now, this would be fun, right? All day if I just gave you line segments and ratios and we put pretty dots and pointed an arrow to the dot I wanted. But that's not what this is for. This is just to introduce you to partitions. Now what I want to do is actually put it on a graph, give you a ratio, and in return, you're going to tell me, here's the XY coordinate that cuts it into that ratio. All right, so we're actually going to put a coordinate to each of these now. So yes, many of you go ahead and graph. Whoa, what happened here? Go ahead and graph directed line segment AB. So again, directed, we're going A to B. Whoa, what is that? All right, we're ready. So I'm trying to find the XY coordinate that breaks it up into a ratio of 2 to 3. 2 congruent to the left, 3 congruent segments to the right. But like we started the ones on the first page, how many equal parts am I going to have to break AB up into? How many equal parts? 5, right? But I'm not going to, 1, 2, 3, 4, 5. That looks good. And let's pick the one that's 2. That's not going to help me. It can be an idea where it is, but it's not going to give me the actual XY coordinate. So we're going to have to do some algebra now, right? Not only are we going to have to do it once, we're going to have to do it twice because there's an X coordinate and there's a Y coordinate. So the first thing I'll help you with is how do I find the X coordinate? Okay, let's talk about how to find the X, and then we'll do the same process to find the Y coordinate. All right, well, X coordinate. How far is it from A to B on the X axis? From -3 to 2. How far is it on the x-axis? How many units? We don't need distance formula here. 5 units. Everyone agrees? 5? All right. So I need to take those 5 units on the x-axis and divide it up into how many equal parts again? 2 to 3. How many equal parts? 5 equal parts. So I'm going to take that distance of 5 and divide it by 5. how many equal parts I need to break it up into. So that'll give me 1, which tells me go 1 unit on the x-axis every time to break it up. Now my question is, though, if I want to get to that 2 to 3 point, do I just go 1 unit and I'm there? Do I go 1 unit and I'm there? No, that would be 1 to 4. How many times do I have to travel 1 unit to get to where I need to? How many times do I have to travel 1 unit? Twice, right? 2 to 3. So I got to go twice for a total of 2 total units. All right, so I need to go 2 total units on the x-axis to get to where I need to be. All right, well, where did you start on the x-axis? We started at A, right? So where did we start on the x-axis? At where? Negative. Everyone see we started at -3. So I'm going to start at -3, go over 2, and where do I end up? -1. So I know half my answer already is going to be -1, comma, we got to find the y coordinate now. All right, ready to find the y coordinate with me? Same exact process as the x coordinate. First thing, what is the distance between the y coordinates of A and B? What is the distance between the y coordinates? What do we got there? I'll call on numbers in the second one, but how far apart are they? 4 units apart. So 4 divided by, I'm still cutting it up into 5 equal parts. Welcome to honors math. Sometimes they won't be pretty numbers or even whole numbers. So that means I have to go 0.8 units every time. But again, ready? But again, I can't just go 0.8 and I'm there. That would be a ratio of 1 to 4. I still have to go how many times? How many times do I need to go 0.8? Oh, be careful now. Here's where kids get confused. I still need to go 2. The 3 is for if I went from B to A. Okay? I always go the same amount on the X and the Y. All right? The 3 is just if I went from B to A, directed B to A, but I'm always going A to B. So I'm still going 0.8 units 2 times, just like I was on the x-axis. I got to go twice. So now I'm going a total of 1.6 units. From, where did I start? Where did I start on the y-axis? -4. So I'm going to go -4 up 1.6. And now where do I end up on the y-axis to finish this? -2 point. -2 point. What do we got? 4? 4? I'm using your use your calculator if you need to. All right, so my partition point should be -1, -2.4. Now, why the heck did I have you graph it? We never used the graph to calculate it. We did all algebra. You graph it to check the darn thing. Here's why I want you to graph it. -1, -2.4. Ready? -1, -1, 2, and a little bit more. Your partition point better end up on your line segment. All right? If I ended somewhere up here, I did something wrong. Right? The partition point should end up somewhere on your line segment. And also, it should pretty much fit your ratio 2 to 3. Like that left side should be smaller than the right side, right? Because I had 2 over here, 3 to the right. All right, so that's why I want you to graph every time, is to check your work. All right, make sure your point lands on the line and it looks pretty much like the ratio you were asked. Any questions? Because this is the same process every time. The only thing that'll change are the coordinates and the ratio. All right, here you go. I'm going to start calling on you guys now. I'll give you a second to graph AB again. And always take a look. Make sure it's directed line segment AB. You never know. Maybe I get nuts and change it on you. Okay, now the ratio is 4 to 1. And now the ratio is 4 to 1. All right, let's go x coordinate. First of all, how many equal parts do I need to break this up into if it's in a ratio of 1 to 4? Here we go. Doyle, how many equal parts am I going to break it up into? 5, right? All right, so let's start on the x-axis. How far apart are your x-coordinates? How far apart are your x-coordinates for A and B? 14. Gianna, how far apart are they? 4 units. Good job. So 4, cut that into equal parts of 5. Again, not going to be pretty every time. I'm going to go 0.8 now. 0.8. But again, you got to understand how many times do you have to go 0.8 on the x-axis, right? Look back to your ratio. How many times am I going to go 0.8 so I can multiply it? 3, 8, and how many times? 4. Yeah, it's always that first number in the ratio. When do I use 1? If I go directed line segment BA. That's when I would use the 1, but I'm going to use the 4 all the time. So that gives me what, 3.2, everybody? Yep. All right. That again, here's the other part that confuses students. They stop here and they think 3.2 is their x coordinate. No. That's how many units you have to go from the start. And speaking of the start, what x coordinate did I start at? Josh, where did I start at on the x?
-2.
-2. So I got to go start at -2, travel over 3.2 units to the right, and I should end up at, what do we got here, kids? 1.8? Is that 1.8? No, not even close. 1.2? Yeah, if I could do some math in my head. All right, so there's the x. Okay, I'm trying to trick you here now. Trying to trick you guys with the y coordinate and see if anybody notices it. I am still dividing it by 5. What is the distance on the y-axis now? What is the distance between your coordinates on the y-axis? Josh again. 8. Now watch. Ready? There is 8. But does anybody notice what's happening? See how you're going down? So to show I'm going down 8, I'm going to put that negative sign there. Now, am I saying distance is negative? No. I'm just saying I'm going down 8 units. The distance is still 8. The negative tells me I'm going down. And I'll show you why that's so important at the end of our problem here. So now I'm going to go down 1.6 every time. Yes, 1.6. Is that what it comes out to be? All right. All right, back to you guys. How many times am I going to go down 1.6? 1.4. Gianna, back to you. Still 4, yeah. Don't use the other number unless we're going opposite. Oh boy, you should think I should know this, huh? 3.2, 6.4. Down 6.4. All right, so that means I got that. That's not where my y coordinate is, though. That's how many units I'm going down from the start. And where did we start on the y-axis? Amy, where did we start? 5, right? So I'm going to go 5 down 6.4. So my y coordinate should be negative, did I get this right, 1.4? All right, so I think, we'll check though. I think my answer is 1.2, negative 1.4. Let's see where that lands. 1 and a little more, negative 1 and a little, oh, right there, look at that bad boy. And that looks good, 4 to 1. I should have a lot more space on the left than to the right. Please don't go on to the next one yet. Let me please show you something. Why it's good to check. A lot of you, no matter how good you are, a lot of you may forget that negative sign and don't notice it's going down, or maybe it's going to the left on the x-axis. Let's say you forgot the negative sign. What would happen if you forgot the negative sign? This would become plus down here, and you'd be graphing 11.4. Anybody see a problem if I try to graph that? 1.2, 11.4. That's not even close to being on the line segment. So that automatically tells you I did something wrong and I need to go back and look. All right, so that is the importance of checking. Something as small as forgetting the down, the negative. All right, you're going to notice instantly that something went wrong when you check it. In your group, you got the next one in your group. Let me know when you're done. Okay, when you and your group agree on the next one, let me know. Don't call me over unless you check it too. Make sure it lands on the line segment and it fits the ratio I asked for. Be over if you're finished. Talk to each other.